Today, we're diving into one of the most important experiments in the history of science. It's the wild story of how Ernest Rutherford set out to prove one thing about the atom, but instead stumbled upon a reality that would completely rewrite physics forever.
And this whole thing really boils down to one central question. What does it actually take to make scientists throw out a theory that everybody thinks is right? Well, as we're going to see, sometimes it takes a result that is so bizarre, so completely impossible, that you just have no other choice.
Okay, so let's set the scene. We're in the early 1900s, and physicists, well, they feel like they have a pretty good handle on the atom. They had a working theory, an accepted model that just seemed to make a lot of sense. This theory was known as the snowball model. The basic idea was that an atom was just this sort of diffuse cloud of positive charge and mass, and the tiny negatively charged electrons, they were just kind of dotted throughout like plums in a pudding. It was simple, it was elegant, and it was the accepted truth. Here's a really great way to picture it. Think of a big, fluffy, loosely packed snowball. That's your atom's positive mass. And then, scattered inside, you've got a few tiny grains of sand. Those are the electrons. This was the mental image that all the top scientists, including Rutherford, were working with. But here's the thing about good science. You don't just accept a theory, you test it. So Rutherford's team put together this really clever experiment. And the funny thing is, they weren't trying to challenge the snowball model. They were trying to prove it. So here's the setup. You've got a source that fires these tiny, fast, positively charged bullets. They're called alpha particles. You aim them at a sheet of gold foil that is ridiculously thin, and then you surround the whole thing with a detector screen to see where those particles end up. The goal was pretty straightforward. See how the gold snowballs scatter the bullets. Now, this is the crucial part. What did they expect to happen? Well, based on that snowball model, those alpha particles should have just blasted right through those puffy, diffuse gold atoms. I mean, think about it. If you fire a BB gun at a snowball, it's just going to zip right through, right? They expected the particles to pass through with maybe a tiny nudge off course. But as we're about to find out, what they predicted and what they actually saw were two very, very different things. This is where the story gets really good. So, did the experiment go off without a hitch? Did the alpha particles sail right on through just like they were supposed to? Well, nope, not even a little bit. What they saw was just astonishing. Yeah, most of the particles did pass through, but a tiny fraction of them, something like 1 in 8,000, didn't just get deflected. They bounced almost straight back, like they'd hit a brick wall. Rutherford himself said it was like firing a 15-inch shell at a piece of tissue paper and having it come back and hit you. It was simply impossible, according to the snowball model. The conclusion was just undeniable. For a particle to bounce back like that, it had to have hit something incredibly dense and solid inside those gold atoms. The snowball theory? It was dead on arrival. It could not explain this result. Period. So this impossible result meant Rutherford had to go back to the drawing board. He had to build a whole new picture of the atom, one that could actually explain what his experiment just uncovered. And this led to a completely revolutionary idea, the nuclear model. Rutherford proposed that an atom is actually mostly empty space. All of its positive charge and almost all of its mass is packed into an unbelievably small, dense core. He called it the nucleus. And what's so brilliant is that this new model explained everything perfectly. Why do most of the particles pass right through? Because they're flying through empty space. And those few that bounce back, well, they were the unlucky ones that scored a direct hit on that tiny, dense, positive nucleus and were repelled. The nuclear model fit all the evidence, where the snowball model completely failed. It just worked. You know, it's also so important to remember that science is almost always a team sport. Rutherford, he's the big name. He conceived the idea. He was assisted by Hans Geiger, you might recognize that name. But the guy who was actually in the lab, who ran the experiment and saw those impossible results, that was Ernest Marsden, an undergraduate student at the time. It's just a fantastic reminder that a huge discovery can come from anyone, anywhere. But this story isn't just about the atom. It's really a perfect lesson in how science is supposed to work. Because making the discovery, that was just step one. Because even Rutherford's incredible model wasn't perfect. Another physicist, the famous Niels Bohr, pointed out a pretty big problem. What was stopping the negative electrons from just spiraling into the positive nucleus?
So Bohr built on top of Rutherford's idea, proposing that electrons had to exist in specific energy levels. And that's the key, right? Science moves forward by people testing, questioning, and improving on the ideas that came before. And I mean, just look at how fast this all happened. Before 1910, you've got the snowball model. In 1911, bam, Rutherford publishes the nuclear model. Just 2 years later, in 1913, Bohr makes his crucial modifications. And of course, it didn't stop there. This single experiment unlocked a whole new era of physics, proving that scientific knowledge isn't some stone tablet. It's always evolving. So, when you boil it all down, Rutherford's story really gives us the playbook for good science. His team took their ideas and exposed them to a tough test. When the evidence blew up their beliefs, they didn't ignore it. They changed their minds. They published their results openly for everyone to see, and they acted with integrity, giving credit where it was due. That, right there, is how you move science forward. And that leaves us with this one last kind of fascinating thought. This whole revolution in how we see the universe began with one surprising result that just didn't make sense. It really makes you wonder, doesn't it? What accepted truth that we all believe today is just waiting for its own gold foil experiment to come along and change everything?